Okay, this is trig derivatives. You'd solve a trig derivative using the chain rule. But for each trig value, there's also a derivative of it. So sine would be cosine. Cosine would be negative sine. Tangent would be secant squared. Cosecant would be negative cosecant times cotangent. Secant would be secant times tangent. And cotangent would be negative cosecant squared. So an example would be, so y equals sine times 3x plus 2. So remember, you use the chain rule to solve this. So next, you'd want to kind of write it out as u. So you're using u. So it would be sine times u. And this is u. Then you would want to take the derivative of sine. So y prime equals cosine times u. And the derivative of the inside, u prime. So now you just fill in the blanks. So y prime equals cosine times 3x plus 2 times the derivative of the inside, which is 3. Now just to make it neat, I'm going to move the 3 in front of the cosine. Y prime equals 3 cosine times 3x plus 2. And then, so that's the example for sine. So here I'm going to write another one. So y equals cosine squared times 5x squared. So now, because of this squared here, it changes it a little bit. You're still going to use the chain rule though. So next I'm going to rewrite it as y equals parentheses cosine times 5x squared. Then I move the square on the cosine outside, so it's all inside that parentheses. Now I'm going to start to find the derivative. So y prime equals, bring the 2 down in front, so 2, open parentheses, cosine 5x squared, close parentheses, to the 1, just to write that out there. Then I'm going to have the derivative of cosine out here. So it's negative sine times 5x squared times derivative of the inside, which is 10x. Now I'm just going to simplify this a little bit. So now it's y prime equals 20x, because the 10x times the 2, sine 5x squared cosine 5x squared. That's it. Now I'm going to show you an example for tangent. Okay. Y equals tangent times 4x to the 5th minus 4x. So find the derivative. So I'm just going to rewrite it real quick. So y equals tangent times u. Remember, this is u. So now I'm going to have y prime equals secant squared times u, which is 4x to the 5th minus 4x times the derivative of the inside, which is 20x to the 4th minus 4. I'm just going to bring that out front. So y prime equals 20x to the 4th minus 4 secant squared times 4x to the 5th minus 4x. Now I'm going to show you an example for cosecant. So y equals cosecant 2x squared plus 9x. So I'm going to rewrite this with u. So y equals cosecant u times u. Now I'm going to find the derivative. So y equals negative cosecant u times cotangent u times u prime. So this becomes y prime equals negative cosecant 2x squared plus 9x times cotangent 2x squared plus 9x times 4x plus 9. Now, then you're done. Now I'm going to do one for secant. Y equals secant times 5x squared plus 3x to the fourth. So now I'm going to rewrite it. So y equals secant times u. Now I'm going to find the derivative of secant. So y prime equals secant times u times tangent times u. Now all this times u prime. So now you just plug in the blanks again. So y prime equals secant 5x squared plus 3x to the fourth times tangent 5x squared plus 3x to the fourth, all times 10x plus 12x to the third. Now I'm just going to bring the 10x to the front just to make it look neat. So y prime equals 10x plus 12x to the third times secant times 5x squared plus 3x to the fourth times tangent times 5x squared plus 3x to the fourth. One more. I'll show you one more for cotangent. So y equals cotangent times 7x to the 8th plus x. So I'm going to rewrite this with u. So y equals cotangent times u. So now I'm going to find y prime equals negative cosecant squared times u prime. So now to plug in the blanks. So y prime equals negative cosecant squared times 7x to the 8th plus x times 57x to the 6th, or sorry, 7th, x to the 7th plus 1. I'm just going to bring this down in front. So y prime equals 57x to the 7th plus 1 times negative cosecant squared times 7x to the 8th plus x. And that's trig derivatives.